Hi, welcome. This is an introduction to probability distribution for machine learning. Lesson 4, calculating probability over a range. Previously, we have seen that we can calculate the probability of observing a specific value using a probability mass function. What if we wanted to find the probability of observing a range of values for a discrete random variable? One way we can do this by adding up the probability of each value. Suppose we flip a fair coin 5 times and we wanted to know the probability of getting between 1 and 3 heads. Let's flip a fair coin 5 times and we wanted to know the probability of getting between 1 and 3 heads. Just we add up the probability of each values and we get the probability over a range between 1 and 3. We can calculate this using the following equation where P probability of X is the probability of observing the number of X successes. In this case, heads. Mathematically represented as probability of 1 to 3 heads equal probability of 1. The value of interest is between 1 and 3, which is including 1 and 3, because it is a range of calculating the probability of the fair coin, which is flipping 5 times. So probability 1 to 3 heads equal probability, the value of interest is 1 plus probability, which is 2 plus probability X equals 3. Then we calculate the probability of each value and we add each the result of each probability and we get the probability of the range between 1 and 3. How can we calculate this probability over range using Python? First, let's import scipy dot starts as starts. Then we use binomial mass function that is used to calculate the binomial distribution, the probability of binomial distributions. That is the best method from scipy library to calculate the probability of binomial distribution. Let's calculate the probability of this heads, which is experimenting 5 times. Starts dot binomial dot pmf, and we assign the value of interest X, which is X is equal to 1, and the number of experiment or the number of trials is 5. N is 5, and probability of success is 0.5 for each experiment plus starts dot and the second one, the value of interest or the head in this case is 2, and the experiment is the same 5, and the number the probability of success is the same. And the third one, which is 3 and 5, 0.5. Now we can print this probe and we get the sum. We get the same result in the above, and that is the probability, just calculating the probability of the outcomes of the flipping coins, which is in the range of 1 and 3 heads. And this is one way to find the probability over the range, but there is another way to calculate the probability over the range, and that is we can first initialize or define an empty list, and for every I in range of 1 up to 4, 4 is not included. It includes 3 because we are going to find the range between 1 and 3. It includes 1 and 3. So we can increase the endpoint of the range by 1, and we get the exact result. Then we append this probability of each iteration to the probability list, prob list, and starts.binom.tmf. Then we assign x, the value of interest is I, and the experiment is 5, and 0.5 is the probability. Then we can print the probability, and we can get the probability of each head, each experiment, each value. Then we can sum each probability, and we get the probability of the range between 1 and 3. To do this, just sum, we can use sum function, and we can just get this result. So this is the second way of calculating the probability in the range. Okay, the second example, if we wanted to know the probability of observing 8 or fewer heads from 10 coin flips, we need to add up the values from 0 to 8. So if we wanted to know the probability of 0 to 8 heads, so what we do here, we just sum probability of 0 to 8 heads plus probability of 9 to 10 heads, because we have 10 trials, so we can experiment the coins 10 times, and we can we want to get 0 up to 8 heads from 10 experiments. So we just sum this, and or probability of 0 to 10 heads equal 1. This is equal to 1. So what we're going to do is probability of 0 to 8 heads equal subtract probability of 9 to 10 from 1, because probability of 1 to 8 heads plus probability of 9 to 10 heads equal 1. So we can subtract probability of 9 to 10 heads, and we get this one. So this is the simplest way to calculate this, and simply we can subtract from 1, and we get the probability 9, the number of interest or heads, and the experiment is 10, and the probability of success is. Then we can print prob. We can get the probability from 0 to 8. 0 to 8 is almost 99%. 99%. So this is one way, simplest way, because it is difficult to add each probability from 0 to 8 heads. So that is difficult. So we can simply subtract 1 from, subtract the probability of 9 to 10 heads from 1, and we get the probability of 0 to 8 heads. That's the simplest way. And the other way, we can also visualize this scenario with the probability mass function using Matplotlib. We flip a fair coin 10 times and want to know the probability of getting between 1 and 3 heads from 10 experiments. We can visualize this scenario with the probability mass function. Now let's first from Matplotlib import payplot as PLT, and we can also import ipy we get, it is a graphical to display the graphical slider as we get. Now let's define the probability plots probability some x. But here, before this, we can decorate or inherit the winged layouts that interact. Some x wingets dot int range slider, and we can assign value in the range for 1 up to 3. This is a default range value, and we can assign minimum to 0, maximum to 10, and description for this is we can to display the sliders. We can simply slide and update the ranges anytime we want, and we get the probability of each. Now let's calculate using loop for loop. We can simply copy this one here. Probability 1. First, let's calculate the probability 0 up to 10. Probability 0 up to 10. Probability 0 for every I in range 0 up to 11 by adding 1. Then we can update this probability 1 dot append the probability of I for from 10 experiments, the probability of success is 0. Then we can print this probability 1. This is the range actually. It won't work right now. This is the slider in the range. By default, it is in the range of 1 to 3. So we can increase or decrease the range, and we can get the values, the probability of between that range. This one is the probability of 0 up to 10, and we can get the result of the sum of the probabilities. This. Now it is almost 1. 0.99 something is 1. So because 0 up to 10, the probability of 0 up to 10 is equal 1. That is okay. The next one is probability 2. That's probability in the range. Then we can create another for loop I in range x index 0. That is the value when you update this. That's the value, the sequence numbers. We can get the first x, this x. We can assign his an argument, and you can get x index 0 automatically get this. When you update this, just take this value, and the end point in this range is x index 1, but it should be increased by 1 to get exact, because in the range should be included in calculating the probability between that range. Now update the probability of 2 and append I which is from 10 experiments, 10 trials, and the probability of success is 0.5. Now we can print and see of between and heads. Let's put it in the percentage format. X in the 0 in between X index 1 and round sum. We can sum the probability of 2 underscore 2, this one, the result of the second probability between the range prob 2, and multiply by 100, and we round this decimal point to 2. Now we can print this, and we can get the probability between 1 to 3 in the range of 1 to 3 from 10 experiments is 70%. 70%. What if it is 5 experiments? That is 78%. We got this in this regard. From 5 experiments, the probability from 1 to 3 head is 78%. The same is true here from 5 experiments, but we want to get from 10 experiments. And now let's visualize. Let's visualize using bar plot. PLT just figure, big size, 6.3. Then first, let's plot the first probability from 0 to 10 experiments, from 0 to 10 heads, and let's arrange in the X side 0 to 11, and the Y side is the probability 1, and we can identify this by color to F or F, and we can title binomial distribution. But we should, here that is the probability from 0 to 10 heads. We should label the Y and X labels here. Y label is the probability, and X is number of heads, and we can grid this to easily identify the probability value. This is, but the slider will not work right now for this bar plot, because the slider works for the second probability that working in the range. So we can simply add this bar, range X index 0 up to X index 1 plus 1, and the Y side is probability 2, And you can simply identify color by green. Sorry, here. Probability 2 and sorry, I forget. This should be between this in the range. That's my mistake I made. Okay, now it's exact. The probability from 1 to 3 heads. 1 to 3 heads. To easily identify, we can set a take heads of X level, KLT X takes in the range of 0 to 11. You can simply sequentially represent the X level. So 1 to 3 heads, the probability is 70.7. We can increase the slider, for example, from 1 to 5 heads. From 1, 2, 3, 4, 5 heads, the probability is 62%. 62%. And from, for example, 2 to 5, 2, 3, 4, 5, the probability is 61 point. It's almost the same. And from 2 to 8, the probability is 97%. 2, 3, 4, 5. The green represented the probability over the range, and this one, the gray color represented the probability from 0 to 10 heads over the range. So this is a simple way to calculate the probability using Python. So Python is powerful to calculate any statistical problems, mathematical problems for machine learning and AI. Next time, we will learn more about the probability distribution for machine learning. And please like, share, and subscribe my YouTube channel. Thanks for watching.